Hi everyone, and welcome back to another episode of the Uncast Show. Well, in fact, I'm not going to say another episode. In fact, it's actually part B of my awesome interview with the great Tom Lawrence. Now, in this part, we're going to be continuing from part A. Well, Tom, I reckon we can't let people wait any longer to start talking about ZFS. I'm sure a lot of the Unraid guys out there, there's been a lot of buzz about ZFS coming into Unraid.
Yep.
But what I'm going to ask you about ZFS is, what's the point? Why do I need it? So can you shed some light on why ZFS is special compared to other file systems people might know?
So I will quote Michael Lucas and call it the billion-dollar file system. And if you don't know who Michael Lucas is, he didn't write the book on ZFS. He wrote 2 of them. And Michael is really a wealth of knowledge to help me understand that file system better through his reading. But too long, don't have time to read a book on it. ZFS has one of the most developed file systems for maintaining the integrity of your data and also giving you performance. And the performance matters a ton in the enterprise world, as does integrity. Those are 2 things that are somewhat opposed to each other if you think about it, because we can always stripe it all together and get really good performance, but no integrity. And that little balance is hard to keep. ZFS has been able to, through an amazing amount of engineering, starting all of its history in the early days when it was written, all the way till today. It was really ahead of its time when it first came out from a structure standpoint, and it's just got the attention of all the right people. Matter of fact, ZFS is in more places than people realize because it is the back end for so many commercial storage products. Even though they may have a fancy name on the front of it, if you could pull back and look at what's under the hood of them, you go, oh, that's just ZFS under the hood. You just licensed ZFS. Yes, you did. That is very, very common. And some companies don't do it as well. So bit rot, when you start dealing with things at scale, we can solve by having extra drives and a parity to be able to validate that. ZFS takes that to the next level with the way their parity system works. It's definitely truly one of the most advanced ones, combined with the way the ARC system works. My friends over 45 Drives did a great video they just published the other day about this, because people don't understand. It's the single drive IOP problem that you should have if you're new to ZFS. You look at it and go, I have 5 drives set up. I shouldn't get this fast a performance out of them because they're all grouped together in what they call a vdev. But the way ZFS works is it takes a bunch of small writes, groups them together into transaction groups, and then flushes them to the drive, which technically ends up giving you this higher level of performance that you wouldn't expect out of there. Combine that with the way it uses memory. So ZFS is this performant, high integrity file system, and I don't think you can even, Btrfs is the only thing I'm aware of that comes close, but does not match ZFS in terms of that performance.
And also, I'm sure a lot of people, when they kind of think about ZFS and they haven't kind of used it before, I get a lot of people say, oh, do I have to have ECC RAM? Do I have to have 1 gig per terabyte? Your thoughts on that, please, Tom?
Yes. You do not need to have the ECC RAM. And I actually have I think it's a 30 terabyte server with 8 gigs of RAM. So does it now? More RAM means more performance. ZFS is RAM efficient. Some people say RAM hungry, but it just doesn't leave any unused. If I took and stuck more memory in that particular machine, it would happily consume all of it for caching. That is the advantage, but it's not a need. It just lowers the bar of the performance. All those performance advantages when I'm talking about, because the entire system has 8 gigs of RAM in it. That is just with over 30 terabytes of data on there. It doesn't perform very well, but it doesn't need to. It's a backup server. That's the reason it exists. Is it just keeps copies of my data. It has a slow random seek. So if I was to start searching files on there, it'd be a little slow, but all it is a extra copy of all my videos. I'm not too worried about it. If I ever have to transfer them, will they transfer a little bit slow? Yeah, but if I'm disaster recovering, then I'm just happy I have them. So,
yeah, right.
But that being said, the ECC is an important one because people keep pushing that myth that you have to have it. ECC is a nice have, not just for, not because of ZFS, but because, hey, what's happened
for everything, isn't it?
Yeah.
Any file system, really. It all goes to the RAM first.
Yep. It all goes to the RAM
with any
first.
file system. So
yeah. ZFS is a copy on write file system, and they call it an atomic write. One of the things that happens with copy on write is there never can be data loss, because, and it's never is not something you would usually use on anything computer. So usually you say, well, maybe this happens or maybe that happens. But ZFS is a very, very complicated but beautifully done system that says there's always a valid copy of your data. We gather up all those transactions and we're going to flush them in an atomic write. So we have those transactions, whatever they are, one or many, whatever would fit into that segment. We write them out. Then we're going to create a checksum of what we just wrote out. And if that checksum fails, so does that write. We got to figure out why it failed. We can unwind that write and figure it out. But that's it. If once that checksum is passed and it validates, so it's already been written, then it's checksummed, then it's committed. Now that data's live. Then we can pull out the pointer for the old data. That way there's never a time where it's an in-between. You may lose in a catastrophic failure the data that was in the queue, but you don't lose the data there. So the write is either completed or not completed. And if it's not completed, there's not a partial write that would leave you in an invalid state. So with some file systems, actually many of them, they will pick up and delete that pointer and start writing. And this is how you get data corruption. If you just unplug a ZFS system, just pick it back up. You'll lose transactions in flight, but those transactions in flight were either committed or not. And if they weren't committed, they're just not there. You always have the previous commit, completely full integrity. This is why if you have memory that's going bad, that would corrupt the data. Absolutely, you're right. But that data won't pass a checksum. You can't checksum corrupted data and validate it. Hence, the write will not complete, and the system will lock up, crash, or whatever happens. But your last known good write exists. This is the entire premise of a copy on write file system.
So, it doesn't matter, especially for a home labber, that you haven't got ECC RAM, because it will either work or it won't with the data writes. Like you say, that if the checksum doesn't pass, you've got some bad RAM and you need to check the RAM and maybe get some more.
Yeah, and where this can help, if I am busy writing from my computer to my NAS, and my NAS does have some memory that is having a checksum problem and I don't have ECC, I could lose the data heading over there, but I'll have whatever data did make it. There's not an in-between. There's not corrupted data on there. The data's missing because it didn't make it. The system died prior to it, so that file I'm copying over there didn't make it, but the last version of that file, if it already existed, if it was a change, it made it. The integrity of that file does exist.
And can I ask you about how that would pan out with ARC caching? And maybe you can just explain to people listening what the RAM ARC cache is.
Yes.
And if you had bad RAM and there was some data in the ARC cache that was going to be read out to a client, there's some stuff that's there that's being accessed lots of times, could that be corrupted in the RAM and then kind of given out? Or would ZFS somehow know that that's not the correct, it's being corrupted in the ARC cache?
I've never had it happen when reading from the ARC cache, because this is such a hard thing to simulate. Could data that's in cache, because now it's been read from the drive where the integrity was validated, but be held in memory where the program running obviously does a level of validation, but could there be a bit flip in between? Possibly, yeah. That would be, I can't read the file. It doesn't mean the data itself is corrupted. It means my version of the data pulled from cache. So that is possibly an issue. It's something that I guess could happen. It seems unlikely, but I would definitely put that on the could. The problem is if someone was reading a file and the file was corrupted and they're scratching their head, but they read the file a second time and it's not corrupted. And if I go to validate it, like they copied the file and I want to repeat the process, if it doesn't corrupt again the same way the second time it's run, because the data on the disk was never affected, that becomes very challenging because it's such a hard to produce problem. So I can't say that has never happened, but it's one of those things that would be extremely hard to reproduce because we can't get a consistent bit flip. But I've been trying to find, because we were, and I want to do this test again, we were yanking memory out of systems. Live systems, trying to break a ZFS system. I did this in a video a long time ago and I want to do an updated version. I got some old hardware laying around and I'm looking we're going to zap it with electricity. We're going to do everything we can to try to corrupt data in flight because I want to see what happens on it. But it's shocking how much ZFS will survive, because that was what fascinated us. We did this long before I understood more about how ZFS worked. What sent me down the rabbit hole of how did this work was me smashing on it and taking and pulling cards out going, stupid thing keeps recovering. Why does this keep working? And that was like forever ago.
Talking about that, I remember I saw a video of yours years ago. I think you were reviewing some TrueNAS system from IX Systems where it had 2 motherboards in it that were connected to the same backplane.
Yep.
And you could actually pull out a motherboard and then CARP would let it know that the one's down and switch over. I thought, well, that is so amazing. I never knew that you could share a backplane.
Yeah.
With 2 different computers, really. That's pretty cool.
It's really clever, the engineering they put into that. It does require that you're using the SAS drives on there, because the SAS drives have dual connectors. So they're able to take that backplane, split it into 2 boards. I had to get permission from the engineers. I said, look, I'll do it once in the video. I said, because normally they want you to power down the motherboard before you pull the motherboard out. I'm like, but I just want to pull the motherboard out. I want to show that I want to simulate a catastrophic failure without destroying your motherboard. You're like, well, if you don't do it too many times, because they said it could actually pulling it out, because I forget how many watts, it's pretty heavy wattage on there. They're like, it will arc internally. You can't see it, but when you're sliding it out, when those connectors pull apart, there's an arc. They're like, that's why we want to power it down first. So I did slide it out once in the video. But the beautiful thing, just like you said, is it didn't miss a beat. It goes, everything's already synchronized. They keep the 2 motherboards in sync with each other at very high speed, so the other motherboard doesn't have to pick up where the other one left off. It's always in sync, mirroring everything, just not committing it. But when it realizes the other motherboard's gone, then it starts actually committing the data. It's just watching all the data, seeing all the open files, and then it goes from there. And
with the virtual IP that they use, was that kind of like set inside the actual server, or was that done on the switch or firewall? Yeah, the virtual IP for the
that's all done on a server.
System.
They're I believe they're using CARP. Yeah, CARP on the back end of that. So the 2 motherboards, they have a backplane. I forget. I did state it in a video. So you have like 10 gig or 25 gig connections on there, but the motherboard themselves also have an internal IP that they share. And that's connected at like 100 gig or more, because that's one of the limitations they have to overcome. And the newer ones, because that was a few years ago, are probably faster. They actually have to create, even though it's done via virtual network, there's an internal network connection that binds these 2 boards together, because that's how they talk for all the synchronizations. They're able to talk to the SATA, but they actually have to synchronize all the information. What's in the ARC cache on each one, the memory synchronization, that all has to occur at incredible speeds to get the back end to work. So it's a pretty good feat of engineering. So when people ask me why there's not an open source version of it, I'm like, well, they're using open source stuff. It's not that there's not an open source version. It's that it does require their hardware to work. You can't just get your soldering gun out and tie 2 motherboards together very easily in the way they did with the interconnects that they did. There's ways to make this work with tools like Linbit and stuff like that. That's how like Synology does it. And there's completely open source ways to do it, but not to the same level of synchronization, because it's the combination of the engineering that went into the hardware and the hardware designers working with the software people to put in all the pieces in the right place. It's not actually software that's closed source. It's just not something they give away, because they give it away with their hardware, but you can't get a copy of it because it's TrueNAS with some modified code in it to support a custom built motherboard. As people always ask me, why does an IX system give that to me? I'm like, they tell you how it's done. You can look at all the tools, but do you have that motherboard? Then you can't do it.
Yeah, I always thought that was like a really kind of cool.
Oh, it's very, very clever. I really think it's neat.
I didn't mean to get kind of sidetracked off there, but can we just talk about ARC cache again, and just if you could just explain to people who are kind of new to ZFS exactly what it is?
It's a adaptive read cache. It is a extremely intelligent system for figuring out at the block level. So when I say block level, the way ZFS works and the way ARC cache works, it's not trying to figure out, did Tom ask for this video file .mov? It's not looking at that. It looks at the blocks that were requested. and it says, hey, you requested these blocks, let's put these in memory. And if you want those blocks again, or really anyone connected to this server wants these blocks again, they're in memory each time. It's constantly shuffling which blocks are in there. This makes ZFS so much better because it allows you to do things like when I'm pulling a video edit, as soon as that first time that's read when I'm doing some video editing, and if you have like my server's got 64 gigs of RAM and my projects aren't quite, one project file may only be like a 20 gig file that it's reading in there, that 20 gig file, all the blocks to it are all in the cache. So when I'm scrubbing along on my video editor, it's just smooth as butter. It's pulling it faster than the drives because it only had the read from the drives once. You will see frequently the adaptive read cache in terms of percentage. You'll see this like it has an efficiency number essentially that you can see with ZFS statistics. You're like, that's a really high efficiency number. The cache hits are somewhere like 80, 90% all the time because you're constantly requesting the same files. Same thing when you use things like a storage server for virtualization. You're pointing this with NFS there, and you boot your virtual machine, and if it's a small Linux VM, you'll find most of that virtual machine seems to end up in the ARC cache. And so it also performs really, really fast, and it's very handy.
With a VM, Tom, say you've got the vdisk, and that goes into ARC. Say the whole vdisk won't fit in the ARC cache. Will it cache
only the blocks
of the vdisk that do?
Yep. Which is really cool. Over time, it'll flush out the parts that aren't used. So you think about the way a virtual machine works. It boots up and needs lots of things. I have to read the vdisk into memory. But over time, it's running an Apache server, maybe a SQL server. It's got these same things it just asks for over and over again. This is why I made it clear and like to make it clear that it's only looking at the blocks. It doesn't have to understand what the files are that's requested. Matter of fact, it has no idea because all it is this large VDI file that is sitting on a disk. But it keeps asking for these blocks. These blocks are asked so frequently, the adaptive read cache, that's why it's called adaptive reading, it puts those blocks that are most popular right to the top. It goes, these are the ones that keep getting asked for. It doesn't really have to know why. It just knows give them back all the time. So it's constantly doing that. Also, once the blocks are off there, if you're using encryption, I pointed out some bugs that came when they moved over to Linux that they've since fixed. But it'll actually decrypt them once they're in memory. So you actually don't have the CPU load the second time either, because we don't have to do extra calculations. So the adaptive read cache will actually unencrypt if there was encryption on the ZFS file system, holds them in there, and it just makes those VMs. I mean, when you run a large amount of VMs, especially if those VMs happen to be very similar to each other, it may find, as long as the blocks match, if someone has a request and it's a matching block, that matching block gets sent to whoever's asking for it, because it's like, well, this is what was asked for. So it's complicated and beautiful at the same time, but it's amazing how well it works and how efficient it works from a storage standpoint.
It's making me think of something in the Unraid world. Obviously, we've got multiple different file systems we can have. XFS, ButterFS, now ZFS. A lot of people run media servers, and people ask me, should they make their, like, say, movie share to be on a zpool in ZFS? And I normally tell them no. My reasoning being is you're not going to watch the same movie over and over again, so you're not really going to be getting any benefit from the ARC cache. But if you are watching a movie, you're going to fill up the ARC cache with data that has really no point in being there.
Yep.
So you're better off to have data sets only for things that can really benefit from an ARC cache on a read kind of point of view. Would you agree with that, Tom?
Yeah, I mean, the ARC cache is very automated, so it's not a big deal to stream a movie. But like you said, unless more than one person is going to watch that movie, or you plan to watch it again, it may not be. As
some 4K movies though, they're like 50 gigs, aren't they?
Yeah. So if a pretty good high density, a good bit rate, a 4K movie. Yeah, I mean, the read cache will read it, but it's not going to hurt anything. So you're not going to see a lot of benefit from it because it's doing everything it can to do a read cache, but it's not like you're going to request that file again. Versus with video editing, it's going to request it, and I'm constantly requesting it as I scrub back and forth because you do linear editing, but you also go, I need to jump back to the beginning of this file, so I'm streaming the beginning of the file again, the end of the file again. So you might see it a little bit more on that use case. It's the same thing for people who are doing editing and things like that. If you're editing just documents, for example, great, you got that directory listing fast, but it doesn't really matter if I open up a Word document and it's cached the first time I opened it, but it's not that big of a deal later. So it doesn't benefit in those situations as much.
Okay, cool. So I wonder if we can move on and just talk about pools and vdevs. Obviously, pools being a collection of devices or disks, and vdevs being the kind of bits of those groups, yeah?
Yes.
So obviously there's various setup options like RAID Z1, 2, 3, like a 0 kind of striping, and mirrors.
Yes.
I was wondering if you could just explain to the audience the differences in those different vdev setups, and what's the kind of like pros and cons and different use cases for each, if that's all right.
Yeah. So with the vdev setups, and we'll start with a pool. A pool is where it all begins. You grab a group of drives, they're all belonging to the pool. The first subdivision, doesn't have to be, depends on your setup and what you want, is the vdevs. We have the data vdevs, we have special metadata vdevs, we have the ZIL vdevs, and we have the read cache vdevs. There's also a deduplicate one, but we'll just, for simplicity, you're not that likely to get much benefit out of deduplication, so we'll skip over that one.
Right.
But if we have, let's say, 20 drives, you don't want the vdevs for the data to be generally wider than 12. So if I had 20 drives given to me, I would say, let's build 2 vdevs, a group of 10 and a group of 10. That makes up all of my data disks. And I get the benefit on these data disks of the read performance across all of these, and I get some write performance benefits because of the way the transaction groups and the way ZFS is going to split the data between these groupings of vdevs. Now, with each vdev, you set the RAID Z type, Z1, Z2, Z3. Obviously, mirrors are kind of obvious that you can group all of these. You could actually take those same 20 drives and make 10 sets of mirrors. That's the mirrored option that we mentioned, which you're like, there's some advantages to doing mirrors because it is one of the ways that makes ZFS more expandable. But if you are looking for storage efficiency, you'll realize that's a lack of storage efficiency because you put them all in mirrors. You get better storage efficiency by grouping them together in the wider, as we refer to them.
Do you think the performance is better if you had them grouped in mirrors, like over the 20 drives?
No, I got to do this calculation again. I believe that used to be a more performance advantage, but in modern ZFS, I don't think there's the same performance advantage that mirrors have over the wider ones now, because of the way it has to do the parity calculations for each of those mirrored pairs. I believe that actually is where the next bottleneck comes in, that they have now made better with the wider ones. I have to double check that to see exactly where that is in terms of performance here. But I know this is one of those things that's changed over ZFS. And this is also a challenge when you're Googling, because you'll find someone with a really good form write-up, and then you check the date and you're like, oh, this is from 2012. Does that still apply to 2024? Well, it's not like ZFS stood still. It is rapidly accelerated to be a more and more performant system with more and more people working on it. And that means some of those bottlenecks that we had before have been solved. But the expansion problem is what pushes a lot of people to putting everything in mirrors. So,
because in mirrors, you only need 2 drives to expand. Yes?
Yep. So if we took 20 drives and we built 10 mirrors, and I want to add a couple more drives, I can just add 2. I can keep adding drives 2 at a time. So that would be a great way to expand. But as you start mirroring each pair of drives, you do realize that there's a cost of what we refer to as storage efficiency on there. There's also a little bit of risk of losing more data because each drive is mirrored. So if you lose a drive, the only other copy of that data is on that drive, and it has to mirror back to that same drive right there. So it can be its own challenge. Back to the wider vdevs, though, the popular way to set this up is Z1, Z2, or Z3. Easiest way to think about those. So if I have 2 vdevs that are 10 drives each, if I have it set to RAID Z1, I can lose 1 drive and all my data is still there. If it's Z2, I can lose 2 drives, and so on. With RAID Z3, I can lose up to 3 drives. And some people go, well, I'm just going to go right to RAID Z3, and they realize, because you now have 3 parity drives, you have lost the amount of storage you have available. And then you're like, oh, but I want more space because I have a lot of movies I want to put on here, or a lot of data I want to put on here. So you're always when the little pull down that lets you choose when you're building a pool, you're always like, which do I want? Do I want to risk it with 1 or 2 or go 3 where I have great confidence, but I can't store as much and I don't have the money to buy more drives?
Right. If I could ask you a question, Tom, for your opinion, say we had 6 10 terabyte drives.
Yeah.
Okay. And we could make, so that's 60 terabytes, and we wanted to have 2 disks worth of redundancy. We could make a RAID Z2.
Yep.
So we would have 40 of redundancy. That would be in 1 vdev, but we could also create the pool with the same drives, and we could make 2 vdevs of RAID Z1s.
Yeah.
So we've got 2 groups, in each group of the vdevs, 1 drive can fail. So we've still got 40 terabytes of usable space, got the same amount of redundancy, but obviously we can't lose any 2 drives out of the 6.
Right.
We can only lose 2 drives out of 1 drive out of, if we lost 2 in 1 vdev, we'd be kind of screwed, really. Yep. But what's your opinion on what would you choose if you were going to choose?
And it's easy to answer. It's literally how my system is set up. I have 8 drives in a RAID Z2. That is one of my primary workhorse areas where all my critical data is right now. And that is a common stuff. 8 drives in Z2 is good. I chose that over, I could have reduced it, or because there's actually 24 drives in one of my main production servers. But I broke them all down into blocks of 8 and then set them up at RAID Z2 for levels of redundancy. You start worrying a bit because these drives are just so big. And when you only have a 1 drive of parity and something goes wrong, you have a lot of write pressure on the other drives to rebuild it when you replace one that goes wrong. So they get really busy. And at the same time, you're adding new data frequently to this. So having extra drives of parity to rebuild that is definitely more confidence, because it can take a long time to rebuild it, and you don't want that risk happening. The other problem frequently is we've all bought the drives at the same time from the same batch. I mean, I do everything we can to randomize that, but you will find in batches of drives when you buy them at scale, they seem to, like we do a lot of these like 45 drives, XL 60 drive storage servers. We did a couple of the 30 ones too, and man, we sold a lot of these. They all work great, except this one that we sold. We bought 2 of them for a customer. They needed a 30 drive unit at site A and a 30 drive unit at site B. Those drives had problems at both sites, and they all were bought exactly the same time. We were like, we're just suspect. We had just right off the first month of production use, 2 drives had failed out of each side on each one of these sites. And we're like, they're physically separated from each other. It's just a bad run of these drives, is our guess. We got them replaced under warranty, and knock on wood, they were fine. But man, it's dicey for a minute, because it also had like 50 terabytes of data on each one of these. So the rebuild time was, because it was in production use, it took, I think, a day or 2 to rebuild.
Having the separate VDEVs, again, when I was talking about the kind of 6 drives, if we wanted to expand the pool, we'd only need 3 drives to expand the pool, right, as opposed to needing 6.
And sometimes that's VDEVs. Why you do it is that works out really well, where you just want to expand in smaller units. And yeah, that's an excellent reason. My flash, I work off of a series of flash drives, which of course are more expensive. So those are in Z1. And I have a replication task. With ZFS replication, allows me to have a copy of the data. It's sent to another server all the time. And so I don't worry about it being a Z1. I have a copy of my data all the time. So that's kind of how I can justify some of the Z1 setups that I have is, it just copies. And ZFS replication is a great feature of ZFS, where we say, take a snapshot and replicate this at this destination, being another ZFS place to land. And because ZFS replication works at the block level, it's saying whatever blocks change. So even if I shuffle all the files into different folders, that's not a block change. That's just a pointer change. So that means a couple kilobytes of pointer data needs to be synchronized, which means as I move my videos I have like a folder process where I move them around. I don't end up resyncing a bunch of data because it doesn't see it as new data. If I rename a file, that's the kilobytes of difference in renaming a file. The large files I have for my video tutorials, are really unchanged outside of their name. So ZFS replication is constantly running. Running on a cycle, and so I don't worry about it. If one of those drives failed, I go, well, I'll replace it. And if I couldn't rebuild it, I know my data is safe and secure, snapshotted on a larger, much slower system is where it's landed. Back to that. Why does Tom have a 30 terabytes of storage on a server with only 8 gigs? It's just a copy of all my data, just an extra copy. So it would slow. If it all failed, it would take me a long time to recover off that box because it also only has a 1 gig network interface. So 30 terabytes over a network interface of 1 gig. Yeah, if you do the math on that, you're like, okay, you're not doing videos for a day or two. I'm like, yep, that would happen if I needed all of them back.
That brings me to a user question, actually. I'll have to apologize to the user because I don't have the question right in front of me, but I do remember it. What they asked was, is there a use case you could consider where maybe rsync replication could be preferable to ZFS replication?
Using rsync? The problem with rsync is the quantity of files matters a lot. So if you're synchronizing 100 files, rsync's relatively fast. Make it 1,000, it's not as fast. Make it 10,000 or a whole traversal tree of data. That becomes really challenging because Rsync has to try to figure out what files you renamed, what folders were renamed, and try to sort all that out and synchronize it over to where the destination is. So Rsync can really slow down, especially that initial. You watch Rsync just pin the CPU and index and read all the stuff off the drives to try to make sure it understands where all the things are. And it has to do the same, going, what changed since the last time we ran Rsync, and then send all those synchronized changes over. ZFS snapshots work instantaneously. It's like immediate, and then figuring out the differential from the last time you sent is so immediate. There's no comparison in the speed of how Rsync works versus ZFS. There is, though, one exception. When you are doing things like I had to unencrypt some data. So if I built an encrypted data set, anytime you use ZFS replication, it's always replicating that data set fully, the encryption, everything in it. That means if I want to unencrypt it, I got to copy it. So I'll set up an Rsync job to go from an encrypted data set to an unencrypted one somewhere. That solves it. The other time is Rsync is great for when I need to copy it to a non-ZFS system. And that happens quite a bit. So I do have, I've done some tutorials more recently on Rsync to show that. And it's almost always, because Rsync is a nice universal language for synchronizing files for things that aren't running ZFS. So those are great use cases for Rsync. Like my Synology doesn't use ZFS, so I can talk to that. Or, Unraid, I'm sure, has an easy way to talk Rsync. So if you need to move the data between those two servers, that's the common language that they would most likely use to be able to move that data.
So I'm going to bring us on to another user question as well. I've actually got this one in front of me, so I can read it out exactly. This is from someone called Gnarly. He says, what is the maximum number of spinning Rust drives that you'd ever put into a single vdev? And how would you describe the best zpool topologies for different performance requirements, i.e. IOPS and throughput? I know you've kind of answered some of this already, Tom, but what's the maximum amount of drives you would put in a single vdev?
I think the largest recommended right now is like 12. It's a little fuzzy because they're supposed to be able to go a little bit wider in the latest iteration, but no one really wants to seem to test that. I got to find the time where I have one of our, and I'm hoping we have a client that's supposed to order another XL60 that we get to play with for a little while. Because the problem is just finding a time to, I'm usually, from the time they come in, I got to get them into production, so I don't have time to do, because the testing takes like weeks, because you build out the array, I have to put the data on there, and then I have to do performance tests, and then I have to rebuild the array, which also means recopying all the data. So it's been hard to deep dive into some of these. What happens when I make it too wide? So generally speaking, 12 is as wide as I want to go. Most of them, because we're just nature of those 45 drive XL60s, we're usually building them out in 10 wide because you have 60 drives. 6 groupings of 10 at Z2 offers you a reasonably good performance spread across those, and I think it's a good way to set it up. I completely ran across someone, I think they had 120 drives, a consulting call that came in. They made one vdev. I was like, amazed it worked, but that's of course why it was a consulting call, because it wasn't working right. And they had a drive it failed and they couldn't get it to resilver. I'm like, yeah, I don't know if it will. That's why I told them, I hope you have a backup of all that data on there.
120 drives, man.
They just never thought about it. I don't know. They had got some. They had bought a series of used equipment, JBODs, and just stacked them all together. And I was like, it was some incredible number of drives. I think it was like 100. But yeah, it was a consulting. I'm like, yeah, we actually didn't do the consulting. They just was a few emails back and forth about it. They're like, yeah, it's not performing right. And I'm like, well, explain your vdev setup. And like, it's one vdev. Well, first they said one pool. I said, yeah, but how many vdevs? And they're like, one. I said, no, I mean vdevs. They're like, yeah, one vdev and one pool. I'm like, oh, that's why you're having problems, is what I told them. And you're going to have to find somewhere to offload the data. And I go, I was hoping you would have a way to do it without offloading data. I said, there's not a way to re-slice vdevs without resetting them. And they're like, well, then we don't really need you for consulting, because we thought we needed you to solve that problem for us. And I was like, unfortunately, it's not a me problem.
That kind of brings me on to another question. When expanding ZFS storage, obviously, we can expand the vdevs, or we could just make a new pool. That's another way we could get more storage. Yeah. But the disadvantage, I guess, of a new pool is everything that's kind of using the current pool, and you want to expand the storage. If you make a new pool, well, it's not aware of that, and you'd have to kind of transfer things.
Right.
So, but I guess there are kind of some use cases where a new pool would be the better way to go, I guess, Tom?
Yeah, sometimes it is. Usually when we're replacing systems where it's just all times it's a whole physical new server, more so than making a new pool on an existing server. But for performance reasons, you don't want to mix and match two drives because you get unusual performance. Now, I have a video I did called Imbalanced vdevs, where I show where you can do this. You can use different drives on there, and ZFS will make a best effort to figure that out, especially when vdevs are different sizes. There's ways to make that work, but boy, you end up with a system the system's going to do best effort, but now you end up with a weird performance problem. This can even happen when you're buying drives that are completely different from each other. Like I bought these group of drives, and then I bought these ones that are faster and newer. And now I've got this weird performance bottleneck of some of the writes happen fast, and some of them are catching up on the other side, another leg here. So that can be kind of a problem, and a good reason sometimes going, look, you're going to use a whole group of different drives, just build them in another pool so you don't end up with this weird performance issue of the system being kind of out of sync, where it requests the data from all the vdevs. But if some of them give a response now and some of them have to give a response later, you end up with some weird performance alignment issues, because that's not what ZFS expects. I mean, it'll work. It won't crash. It just won't give you the IOPS and throughput that you're looking for.
So when you first make a pool, it's best to have all of the same drives, all of the same brand. I shouldn't have, say, some 16 terabyte Seagate, some 16 terabyte Toshiba.
Right.
They're all 720 RPM, but I chuck them all in. I'll be much better off to just have everything the same. Yeah.
And for our business clients, that's, more common for them to buy a system and put it on a 5 to 7 year life cycle. We always say 5-year life cycle, but I know I always joke that I tell you we should buy a new server in 5 years, but 6 years I'm bugging you going, hey, did you see that quote I gave you last year? And they're like, but it still works. And I'm like, yeah, it's out of warranty. Anyways, this is where I'll say something that will make the people listening probably very happy, is ZFS is not the solution for everyone. This is where there are absolutely, I will fully admit, times when you need that level of flexibility because your budget does not allow you to buy 60 14 terabyte hard drives at one time. Your home lab budget is, work gave me a pile of hard drives, and then they gave me another pile of hard drives, and I want to use all of them. And it may not be the best solution to use ZFS. It may be better for you to use something that allows you more flexibility with the drives, a system that will allow you to expand later, and that's fine. The benefits and performance of ZFS are awesome, but the reality is I can watch a 4K movie on a hodgepodge of drives with slower performance. What's your goal? To watch movies and have all there, or just view your photos? No problem. You can view all your photos. They're not going to be as fast, but they don't need to be. Your benchmarks won't be as high, but benchmarks are benchmarks. Can I watch a movie? Is like the bar is, what are you doing with it? Will it fit the use case that you're doing? If it's streaming that 4K movie, awesome. And if it doesn't, perfect. It's a solution that works for you. I'm always very honest with users about that. My solutions are my solutions, but not everyone has exactly the same needs or demands that I may have. So the other solutions are completely valid. I think they're good use cases. And sometimes I'm not going to try and shoehorn someone into a solution that's not going to fit them.
I'm not sure if you've ever tried it out at all, Tom. In OpenZFS, I believe in kind of some beta form, you can actually expand a RAID Z1, RAID Z2 pool by adding a drive. It's not in the kind of mainline OpenZFS, but it is a beta feature. Have you ever tried it at all?
I have not. It's been on my to-do list to play with it. It comes down to time. I usually wait till things come to more production because then I can do videos on it. I spent so much of my time doing like production level work, and I'm like, I want to try the shiny new things. I really want to try DRAID, which just now made it to production, which is I can't explain.
That's only for like over 100 drives normally.
Yep. Yeah, it's for the large scale deployments.
Very big.
DRAID's really cool. I have played a little bit with it. I do know it does have some performance disadvantages for certain scenarios, but it's one of those things I haven't had enough time to really flush it out. That's why because people ask me, when are you going to do a DRAID video? I'm like, I've learned how complicated. The more I play with it, the more I realize where my knowledge gaps are with it. And I try to make sure I'm very thorough on knowing something so I'm not explaining it improperly. So yeah, but DRAID is one of my next things that I'll be diving into, which means eventually I will be getting to the ZFS expansion. I'm excited for it. I'm loving to see it. To my knowledge, it's all a one-way operation. Once you expand, there's no way to contract, which makes sense. But yeah, it's not something I've really spent the time testing, but I want to, because I want to actually set up a Debian server with the beta everything of ZFS on it, because I have some things I want to test, because they also have some updated. See, deduplication has a huge penalty in terms of performance. Obviously, in concept, deduplication is great, but it's so limited in its use case. But IX Systems and Clara Systems did a giant code commit to really enhance how that works. And I think they said they made the performance something like 20 times faster. But that's, once again, early beta. I would like to actually see how that works. And so it's on my to-do list to test all these fun things.
I wonder if we can just move on, Tom, to kind of like the special supplemental vdev. I know there's one called a special vdev.
Special vdevs.
But I'm meaning special vdevs that aren't data vdevs. I'm probably calling it the wrong thing. But this is something that's just recently been added into Unraid GUI with the L2 arc, the slog, and the special vdev. So basically the L2 arc is an expansion of the arc cache. Yeah, so for read, so if you don't have enough RAM to cache, you would add one of those drives. I'm guessing you wouldn't need a mirror for an L2 arc. So basically, you're getting more things cached, but I've also heard it can be detrimental to some use cases because it will use more RAM as well to keep track of what's in that arc cache.
It's one of those things. It may not help you as much as you think. Always my first answer, if someone says, the more performance I want out of ZFS, how do I get that performance? It's always add RAM. RAM is your first line of defense when it comes to performance. Like, you want more performance, just keep throwing memory at it. We frequently sell servers. I mean, I have a few of them. I think we have one of them that has a terabyte of RAM in it for a client because of all the stuff on there. So, I mean, and ZFS uses all of it because there's so many things coming in and going on that particular server. But if you have a series of spinning rush drives and you pop an NVMe in there to be your L2 ARC, that can be pretty helpful because NVMe is going to be faster than the other drives, but you also have to have those frequently accessed files. And as long as those files are frequently accessed, they will be pulled off of that drive. And yeah, you can definitely get a performance boost out of it. So that is one way to enhance it. I don't know that the detriment's that bad of the memory to keep track of what blocks have been moved to that. I can't imagine there's that much of a detriment to that. I've never really calculated just how much RAM is allocated to that.
Okay, that's good to know. And then going to the slog, which is a write cache. Yeah?
Yes, but kind of a write cache. This is where it's really complicated. And the problem with a slog is it is ZIL, or the intention log. And it's what you intend to write. It's only really something important if you're doing synchronous writes. Like with NFS, it'll do synced writes versus unsynchronous writes. Unsynchronous writes will commit.
And synchronous writes, to people listening who might not know, is when it needs confirmation it's actually been written, correct?
Yes, and in the ZFS, you could turn that off, and it'll cause tools like NFS to lie. As like I like to say, it says the tool, whatever's connecting over NFS, will say this has to be a synchronous write, because NFS has an option to say that. Which, of course, things that care about integrity tell virtual machines, database connections, they want absolute synchronous. They want to confirm it's committed before they flush it from their memory. So ZFS can be told to lie, say, just tell them it's committed, even if it's not. And that means you could lose up to a few seconds of data. But there's a double write penalty, because first we have to write out the intent log to our data vdevs, and then we have to actually make the full commit of flushing that on there. So synchronous writes come with this double commit problem that really slows you down, like substantially. And the way to get around that is to have something faster. The goal is always have a ZIL that is substantially faster than what you're writing to. So once again, we'll go use the same Rust scenario, and we want to use an NVMe. And now we're going to get some performance benefit out of it. You're not going to get as much performance benefit out of a standard SSD. You get some, but not a lot, where you wrote to the intent log that allows the data to be streamed out to the drives in a transaction commit. If you're running, and I have a video I was working on for this, I just haven't finished it. I was showing that if you plug in a NVMe along with fast SSDs, there's barely anything that the ZEL helps with. It doesn't do near as much because the SSDs are already relatively fast. There are solutions, I think, like some of the the Optane memory, where it's even faster than NVMe. Then certain motherboards allow that. I think Jeff from Craft Computing did a video on that, showing how you can parse that out to be your ZIL memory, because it's even faster, and now you have a better commit. The other option is having ZIL memory that is a high performance cache designed to be ZIL, which there are ones like this. There are different drives that are enterprise drives with very high queue depth, and that will help with performance as well.
Are those like special drives that use RAM and they have like a battery kind of backup?
Yeah, there's ones like that. I can't remember if it's there's a couple names of them out there. Matter of fact, it's funny because you can buy these secondhand now on eBay. If you type in like ZFS ZIL in eBay, you'll actually find used enterprise versions of these. Wendell from Level 1 Text has actually talked a lot about these drives, of how they're so affordable, and he's got a whole video breaking down where to find them and things like that, because their prices, what was enterprise expensive of yesterday is home lab of today, and still pretty performant. So
and for the ZIL, you don't need a particularly big drive, do you?
No.
I think some people, they think they need something really large, but you don't at all, do you?
No, it's the Clara Systems actually has a good write-up on this, like a calculation for how big you need, but it's only the amount of data that can be written in a couple seconds, because it flushes every few seconds. So it's only some amount of data that can be written over this short period of time. It does not hold all the writes and then commit them. So it's not like I'm sending 10 gig file and it writes a 10 gig file and then commits it later. No, it's sliced up to every few seconds it's running, because it's a flushing process. This is part of that atomic rate process with ZFS, where it grabs these transactions, all these little data bits that need to be committed. It's now committed some to ZIL and some to the data and some in memory, and it commits them and does that right, and it starts that process over again, over again. That's why when you do turn synchronization off and you say, hey, just leave it in memory, but then I yank the plug out, that transaction group, when I yank the plug out of the system, or if it were to suffer a catastrophic motherboard failure and wasn't one of those fancy dual motherboard systems, it will lose that in-memory transaction group. But if you had a ZIL and it was written to the ZIL at the same time, it does have one more place that next time you start up ZFS, it goes, hey, is there enough information on that ZIL that I can rebuild that transaction group? Why, yes, there is. That's why we wrote it to two places on there. So there's definitely advantages to having it, but you got to think about what that risk.
So I guess for things like databases, it's really important to have something like that. But for the average kind of person at home, the home labber, you've just got your average kind of Word documents and things like that. A few seconds worth of data is not going to be a really big deal.
Exactly. When you talk about databases, they're very transactional, and you can't lie to a database server and expect it to go well. If the database says someone purchased this product and we want to commit this data, and it says I want a synchronous write commit, and you didn't you told it was committed, but then something happened when it wasn't. Now we just lost that transaction. And from a business standpoint, that's terrible. So when it comes to things, databases specifically, there's no exception. Those ones always get sync rights on, and for performance reasons, because databases are generally tons of small transactional data, you pretty much universally put ZILs in those, and just to make the everyone's life a whole lot better. Everyone can sleep a little better at night, because man, unwinding a broken out of sync transactions on database, no sysadmin wants that.
And also, just for people kind of new to ZFS, you can actually choose per data set which has synchronous and asynchronous rights on the data set level, can't you? It's not on the whole pool level.
Correct. That can be chosen on that level, and you can choose the block sizes on a per data set level, because if you're doing a database, it may be better to set the block size smaller to the commit size that matching the database, or if you're using larger files, it may be to go bigger. By default, I think ZFS datasets are set to a block size of 128K. I think that's actually kind of a generally accepted default, which works fine. It kind of like, we put it in the middle of the road, you're going to get pretty good performance out of there. But if you have some use case that has a need for higher levels of performance, then yeah, you can tune it to align better to your use case.
And I've got a kind of bit of a slightly off topic question. If you were going to set up, say, a VM, would you rather have a data set with a vdisk in it, or would you rather have a Zvol, and why?
So this varies. If I'm using iSCSI, that's going to be a Zvol, because iSCSI presents block storage to other devices. So iSCSI, I've actually, my gaming system is tied to my TrueNAS, because I have just a smaller boot NVMe in my gaming system, and then it does an iSCSI mount. So that's presented as block storage, which means it's going to be a Zvol on the back end, and it performs really, really well. All my Steam library is on there, and all my games lit up really fast off of that system. So that setup works quite well. And so yeah, Zvols are really good for that. If you want to run a virtual machine directly on a system that also has ZFS, same answer. You probably want that virtual machine running as a Zvol in there. But swing it to the other side. I use a lot of XCP-ng. I use NFS shares for doing my shared storage. And so that's going to be in a data set, because I'm letting it handle creating all those disks. Now, the nice thing is when you're doing it that way, it's easier for me to see. So if I have 5 VMs, I also have 5 disks that I can see on that NFS share. So if something goes wrong, or I want to snapshot those disks or rewind to a point in time on the ZFS side, I can look at those snapshots, and it gives them a UUID, but I can reverse that and go, okay, I know that UUID is related to this virtual machine. I like being able to manage them in that way versus the block storage way. Well, you have to manage them on whatever created the block storage. ZFS just presents the block storage. The other side is the thing managing it. This is where we've had trouble with people who used block storage and Hyper-V. Hyper-V actually has some weird quirks about the way it handles block storage. So you have to be that much more careful, because you can snapshot it, but rolling it back, there's a lot of nuance to it. I don't remember if it's fixed in the latest version of Hyper-V, but it has some versioning it does that it doesn't like going backwards. We learned where I learned through someone else's learning experience. It was a consulting call. It starts with a TrueNAS consulting, and I'm like, well, I'm not a Hyper-V expert. I go, oh, this is completely a TrueNAS problem. Actually, it turned out to be a Hyper-V problem.
Well, thank you very much for that, Tom. I'm going to move on to some of the user questions. I've got a few user questions, if we can just kind of...
Yeah, absolutely.
Someone's just asking basically how ZFS replication works. Well, we've already spoken about that with it transferring the blocks, but they also ask, how do you actually store, how do you actually restore from a replicated snapshot? In TrueNAS, you can just do that through the GUI, but currently in Unraid, you can't. So I'll probably answer this question. There is a plugin called ZFS Master, which allows you to take snapshots and restore. You'd need to have that plugin to restore from the snapshot. But also they might be talking about how they'd restore, well, that would be a local snapshot, but a replicated snapshot on another machine. You could just run the ZFS send and receive in the opposite direction.
It really is as simple as that. The data can be reversed, essentially. You just go to whatever process you use to get it going that way, and you make that process choose the other way. It depends on how it's set up. There is push or pull, because you can take from machine A running ZFS and you have machine B running ZFS, and we want to do a push. But we can initiate from machine A pull to pull the data back in the other direction. So if you were actually scripting all this command line, that is an option to do it, to go, hey, let's do a ZFS. We push the data there, but now we're just going to update our script to pull the data back. One of the things I do recommend when people set up these backups is think about that. That way, if you're having to deal with the backup, which usually when something goes wrong with your primary machine, you have to refer to your backup, you're under duress, or if you're doing this in a job, you're put under duress by the people above you going, where's our data? So do practice this a couple times and ask that question prior to it being a problem. And also, I've always said untested backups are just wishful thinking. So test your process, because you can tell it to restore not to the same place. You can pull and give it a new location. That way, you know the data will come back from where it was.
And also, a similar kind of question, I guess. What's the best way to move zpools from one server to another? I guess in a way of, say, you take down your server, you're going to build a new one. Is it better to just replicate the data to the new server? I guess if you've got enough drives, that would be great. But you could actually take it down, put the drives into a new machine, and then re-import those pools in, correct?
Yeah. So I often, it's fun because if you're new to ZFS or new to RAID, like you're a newer user, you think, cool, I can pull these drives out and put them somewhere else. And you're correct. If you're an old user, you remember the days of the early RAID where if you swapped one drive to a different location, your data was going to not necessarily be where you think it is, and it may not work. ZFS labels the drives that are part of a pool. That pool label, even if you have encrypted drives, the pool label is visible. So if I called it Tom's pool, well, if I stick these in another drive, they're still called Tom's pool. The drives all have a marker that is part of it because ZFS controls it right to the drive level. So there's a marker on there that says we're all part of a pool. It doesn't care what slot they're plugged into or what controller card they're plugged into, as long as ZFS can talk to them. So grabbing 10 drives and slapping them into another system and loading it on there and going, hey, import this pool, no problem. It'll work perfectly fine. It's actually a common way to do that because, let's say, even if I am rebuilding with new drives, I can tie the machines together and transfer the data. Or if I have enough physical room in the box, I take those drives and put the other drives and put them all together. That's going to move faster because I'm moving at the whatever the limitation of the drive speed is versus drive speed versus network speed limitation between two boxes.
Kind of going back, it's kind of made me kind of think a bit, going back to your video with the two motherboards. You can see I'm a bit obsessed with that one there, Tom. How did it, I guess obviously the software is dealing with it, but obviously the pool wouldn't have been exported properly when you pulled out the motherboard. It would have been, so I guess it just force exported it in on the other one.
It's
because it wasn't exported correctly.
Easier than that, because what it's doing is the two OSs are in sync live. They're actually seeing the file shares. So active server and the non-active one. The non-active one actually knows what files are being moved. It knows what shares are being used. So it's actually in sync. So it doesn't actually have to import or export the pool, because it's kind of like mirroring a whole operating system at the same time. It's really that level of clever that makes that work. That's why it fails so much faster than other systems that are similar. Because someone, I've done the demo with Synology, and Synology uses two physical boxes essentially to do it. That has a slower failover time while it passes things over. They keep things in sync, but it's a little bit slower when you're dealing with boxes. When you do the engineering, as I said, to keep a really, really fast backplane, it fails over faster because they're more aware of each other. It's not just saying it's your turn to take over. It's like, I'm ready to take over as soon as you quit, because the non-active one keeps asking, is it my turn yet? Essentially, like it asks for it. It's got a pulse. If the moment it doesn't ping back, it goes, my turn, I take over. You didn't respond, and it makes it kind of interesting. But yeah, I'm as fascinated as you. Like, I love the engineering that goes into that, because it shows that you have a very technical background. Because when you see something that seems not impossible but improbable in our tech thing, you're like, okay, there's a level of engineering. There's something missing in my understanding of it for how that could synchronize as well as it does. That's what makes it fascinating. Versus some people go, oh yeah, they stuck two motherboards in there. But I'm like, but do you know what that took? It's like people who think about aviation, or like when you learn how heavy a plane is, you think, oh, planes are, there's some weight savings. When you learn actually how heavy it is, you're like, oh, and it leaves the earth. It flies. You go, there's a lot to this. There's a lot of engineering that went into that.
So I've got another question from Adam M saying, do you have a top five list of best practices when setting up any ZFS based NAS? Any kind of best practices you can think of?
The first one is going to be like the poor soul that had made too wide of a vdev is don't make it too wide. Not something that's going to be a huge home user problem. They generally, unless they acquired a bunch of old equipment, don't have 100 drives to build their pools with.
Yeah.
But I mean, I know there's Reddit data hoarders exists, and there's certainly people that have an absolute wildly large systems, which is cool. Not making too wide. But planning your backups and testing your backups are always, like, after you get it built, document your build process. This is something really important. So you understand how you got to where you are, then making sure you back up your config files. Definitely, once you've taken the time and effort to build those shares, set those permissions, build those users, export that config file. I realize a lot of users, being very privacy focused, choose the encryption option, which is fine. There's nothing wrong. Encryption works well. But unfortunately, some of them forget that if you don't back up the config file, and I do both, I back up the config file and then I export the key. There's a key that's created when you say, I want to create an encrypted pool. And it becomes very seamless because that key is loaded every time the system boots up. But if you lose your boot drives, well, that key's not going to be loaded. So making sure you have that backup. And this kind of goes back to the replication problem of when you set up ZFS replication, if you replicate an encrypted data set, the destination server only gets the data set, but not the keys that go to it. This is a good security where I can, me and you could set up a backup. I could back up all my data to you, but you wouldn't be able to see it. You'd just see an encrypted data set. And I could pull that data back, and because I have the key, it would decrypt on the fly. But if I lose my main server and I didn't back up my key, I'm like, cool, let me build a new server, and then I could still pull that data back, but it would still be as encrypted as it was for you. So backing up the key. So I'm going to say, don't go too wide on the vdevs. Probably not a big deal. Make sure when you set everything up, do your backups of things. Make sure you understand if you use encryption that you have a backup of the key, and then testing your backups. Those are probably, I guess it's only 4, but I think those are 4 good pieces of advice. Like I said, untested backups are wishful thinking. So go through that process once you have it set up to make sure you know how to pull some data back, and you can land it somewhere else. That way you're not being destructive to your existing data. But yeah, make sure you understand how that process works.
Thank you, Tom. Just to kind of like round off everything, I think we've spoken about ZFS for quite a long time. I'd like to just know, really, what is your favorite open source projects at the moment and why?
Ooh, I am actually pretty excited. I've been talking with the people over at NetBird. They are, check them out. I think it's netbird.io, really simple website. If you Google NetBird VPN, you'll find them. They're a fully open source with a lot of active development VPN product, very much like Tailscale. Matter of fact, it's extremely like Tailscale, but open source, not just from the client side, but from the control plane side. So I'm pretty excited about that as a project. I just fascinated by it, it solves that VPN problem. It uses WireGuard. They have a phone app for iPhones and Android, as well as like all the other operating systems. So it's not like a half-baked project. It's a fully baked project that seems to be getting a lot of attention. So I'm excited about that.
And what kind of services are you kind of running in your home lab? Like, kind of, do you run things like, for your own personal self? Do you run things like Nextcloud? Do you have like a media server?
Media server, is MB open source? I don't know.
No, okay. Jellyfin is.
Yeah, Jellyfin's the one that's open source. Someone asked why I wasn't using it. I have a lifetime subscription to Plex, but Plex kept causing me a headache. I don't know why. I had these weird stuttering issues with it. I did everything in my power to solve that. I could not. And I found other people with the problem, which is also aggravated. And someone said try MB, and I did. But I really want to try one of the open source ones because I prefer open source. But MB, like, I loaded it, and it worked, and my wife uses it a lot, and she's like, "Hey, we can watch movies again." I'm like, "All right, that's where I stopped," and I should go further on that.
Yeah, I use MB as well. Well, I've got MB and Jellyfin, but Jellyfin, when MB went closed source, they just forked it, and it basically is MB.
Okay.
A few years ago, obviously it's developed well. It's really nice. Definitely worth. Definitely.
Yeah,
worth
definitely.
Trying
I'll have to check that one out. I use a lot of pfSense, TrueNAS. Those are probably because that's what all my video production runs on. It has for years. Lots of XCP-ng. I don't have a lot of other. I try going back and forth. I use Nextcloud once in a while. Someone's going to not like this. I use SyncThing all the time, and I use local documents. I don't really use the web-based documents. I kind of like, if it's a personal document to me, not direct business related, which usually runs in one of the cloud services because it's business documents and it's easy to share. My personal documents and like notes I take on things, that's all local files. And I use a tool called Rsync for all my markdown files, kind of my journaling, because I started journaling late last year, and I regret not starting that sooner. Where Rsync is similar to Notion, is what people may be familiar with. It's not a one-to-one replacement, but it is a nice open source tool with sync thing on the back end, moving my files around. But I'm still a local documents with OpenOffice guy. That I know probably puts me as weird. So everyone's like, why aren't you using Nextcloud? I'm like, I don't really share it with anyone else. It's just my documents. There's no other people to share it with.
Yeah, well, that makes sense.
Yeah.
I've got one last question for you, Tom.
Absolutely.
Basically, I just wonder how you foresee the impact and future of open source projects in the tech world. Do you think they're going to become more or less relevant moving forward?
I think more. I think we're seeing a time right now where it's got to snap back the other way. The fact that we can articulate so well, like I said, with even Cory Doctorow mentioned what was that quote? I remember a time before there weren't just 4 websites with screenshots of the other 3. And I'm like, that is the status I think we have reached with a lot of it. And it's not the way the internet was founded, but I think it's the way the internet can go back to be, is a more decentralized system. We have a larger ecosystem of open source projects like we did in the beginning, because that's what brought us the beauty of the internet. IIS, in Microsoft, like their web servers were like the earliest days of the internet. If it wasn't for the open source movement and things like Apache, the closed source companies couldn't keep up. They couldn't iterate. They couldn't provide us a product that scaled. So the basis of the internet today is that open source movement of the 90s and early 2000s of this collaboration and sharing and building it. And then it was kind of taken over by the hyperscaler companies going, cool, we can do all of this. But there's even recently, I can't remember the CEO of one of the AI companies. He says, no, the future of AI isn't centralizing it into one big mega server. It's offering open source models that people can run themselves. And I'm like, yes. Decentralized AI, I think, is a much better idea, where each of us have the ability to play with these models, load them on our machines, find their utility and their usefulness without them being part of some larger company. And we've seen great progress for those. Matter of fact, some of the open source models are really competing with ChatGPT and things like that. So somehow the company with an unlimited war chest of money from Microsoft, that is some of the largest money we've ever seen given to a company individual like that, is an incredible amount of money. And then they have a product that's good, but we're also looking at the product we're seeing on the open source world, go, wow, I can actually do something pretty similar without having some giant company slurp up all my data, and I can build some utility of this. And this is where
it's super important, Tom, isn't it? A company doesn't want to be just having all of its data analyzed by ChatGPT, OpenAI. They need to have their own on-prem AI where the data doesn't leak out to some other place. I think that's really important personally.
When I look at this from the perspective I see, which we do a lot of the consulting, and we're watching these companies starting to become cloud adverse. First, the bill came and they go, the bill's kind of high, and every year compute gets cheaper, but the bill doesn't. It gets higher, which doesn't equate. Like there's some people that, like, they're not technical, but they have a very logical question going, don't computers get cheaper every year? Doesn't storage get cheaper every year? But why does my cloud bill for the same amount get higher every year? I'm like, yeah. And then they told us they were better at managing things, but they're in the news for data breaches. So we're starting to see companies. And when I talk about all these storage servers we're putting in, some of these are pulling companies out of the cloud. They decided that it was better to host the data themselves. It was better to have it. Matter of fact, some of the large companies that have multiple locations are like, wait a minute, we can buy 2 servers and we can put one at location A, one location B, and replicate them to each other. Yeah. And it will save us like $20,000 a year in cloud bills. Yes. It's a $100,000 project, and they're like, but we can still even put more data because we're actually restraining the data. So it actually is more, our bill would have been higher, but we decided not to put that data in the cloud. So yes. And when we start doing that, we can start piecing together. There's a great article by 37 Signals. They thought they could save $5 million a year was their goal. We want to save $5 million a year in cloud costs hosting Basecamp. I think they said they sold, after a 2-year analysis, they saved $7 million a year, because what they didn't predict is that the cloud prices kept going up. So their delta ended up for how much money they saved. So it comes all the way back. How are they doing it though? Well, these open source tools they're realizing are really good. They're like, oh, wow, we're hosting all this on open source stuff in our own they are using a colo, but a colo is not exactly the same as a cloud. They needed some resiliency. But you have some stuff in the colos, then you can do lease lines to your buildings that aren't that far away where you have another copy of everything. So you've built the same level of cloud redundancy, and that sounds complicated and expensive, but they run the numbers and they go, no, these cloud companies have raised the price to where this is affordable, and the open source tools make it manageable. It didn't take, the cloud companies are like, oh, you'll need a team of people to manage this. Turns out they don't. It's the tooling has become really, really good in the open source world to make this a much more tenable solution.
As well, I was speaking to Yosh from Nextcloud, and he said something that resonated with me. He said, basically, one day you're going to have to move your data or keep paying for it forever.
Mm-hmm.
So you may as well make that one day soon.
Yeah.
and save the money.
Yeah. We haven't seen a snapback yet, but it will happen when Microsoft, they upset a lot of people because they raised the prices of their cloud storage, which is pretty much, the whole Microsoft Office Online, Office 365 suite and everything like that is universal in the business world. It's unavoidable for most of these companies. But you got a company that is worth, well into the trillions of dollars that says, we had to raise prices to make more money. And you're like, you're already a monopoly. What do you mean? What was there market competition from Nextcloud? You were worried about them and you had to beef up your servers. You just raised the rates. We've seen your earnings call. You weren't hurting. You're profitable. You weren't losing money every year. Oh, we offered this cloud service too cheap. We're just bleeding money, man. We only bought 3 yachts this year. But we need a 15%, 20% raise in rates. You're like, do you need 4 yachts this year? You seem to be quite profitable. But that's what these companies are doing when they get that kind of market hold on you. And like you said, if you don't move your data now, it gets harder. They're always looking for ways to keep you locked in. The egress fees, like, oh, you want your data out? Well, here's your bill for taking it out. Here's your bill for keeping it here. Here's your other bill for removing it. You're like, crap. I paid to get it there. I paid to hold it there. And if it egresses, there's an egress fee to get it back out. Okay.
It's just being held for ransom, isn't it? Really?
Yeah. Oh, and don't list your directories. There's transaction fees that come with some of these storage. Like, oh, you requested too many listings of your directories. Let me add those transaction fees. You only have the first few free. If you want to know what's in there, and you'd run an Rsync on there and it does the transactions. This has been problems people have run into. Like, I got hit for a bunch of transaction fees because I kept rerunning my backup and it kept indexing all the files. Like, yep, there's your bill for transactions. They're like, that's a thing. If they can figure out a way to monetize it, it's a thing. That's how that works.
That's crazy, isn't it?
Yeah. I love when you look at your bill for some of these large block cloud storage stuff. You're like, they figured out a way to put a fee on everything. No one knows how that. It's like just pages of complexity for the sake of complexity to make it hard for you to figure out what your bill is. Yeah. You don't realize how much you save by bringing it back. But we definitely deal with a lot of companies who do, very large companies. We sold 2 petabytes of storage recently to a client, and they want to buy 2 more petabytes. That's how much they're pulling. Well, first, it was the cloud was too expensive to hold the data. They didn't have 2 petabytes in the cloud, but that was why they didn't have. They actually have the ability to create more data for what they're doing analytics on, which is a bunch of engineering data. But it was not tenable to do this in the cloud. They're like, the engineers are like, hey, this is what we need to do. And people go, well, that's what the bill will be. And then finance goes, no, you can't do that. But when we came to us as a solution, like, we have this data problem, we need this much data. We're like, well, we can put this data in here. How much should it cost? Well, one-time cost of this. Well, that's it. And I'm like, yeah. And like, well, you know how big our cloud bill is? I said, probably more than that. And so they now were able to do the thing they wanted to do. They were able to collect the amount of data at the rate they wanted for their engineering team, then to process and build these models they wanted to build. It's a huge company here doing this, but it actually made it affordable for them, hosting it all inside their own data center to crunch on that. They're like, wow, we can just stack these systems and build 2 petabytes of storage, and it doesn't have this constant recurring cost with it.
That's really good to hear. Companies are doing that for sure.
Yeah, I wish I could talk about it more, like
they can work
public
better
setting
and save money.
Yeah, I do wish I could talk about them more. Like, they're very private about the fact that I can't do a video like me being at the company. I can talk about the project. I just can't say the name of the company doing it. I'm hoping, we're trying to get more companies to open up about it, because everyone's afraid that they're going to fail if they try to do this. And I want to showcase you can. And it's a good idea to do it. And that's how we start pulling back from the hyperscalers. They're not the only solution out there. They're the safe bet for the CEO who doesn't understand the complexities, or I should say CTO, whoever the technology person is. They're scared to try it because they're like, I I'm extracted away from what hard drives are when I store stuff in Amazon. I don't think about hard drive. I don't know what a RAID Z1 or Z2 is, and I don't have to because I just give money to Amazon and they always make sure my data is there. They thought the learning curve would be steeper to bring that in-house, and they realized this ain't that hard. But it takes a lot. They're like, it's like when you think about that volume of data, they're like, are you sure it's okay that I have it? I can, you know what I mean? Once they realize the tooling has gotten so good, they're like, okay, it's not too bad.
Yeah. Like, as soon as they learn other companies are doing the same, it will encourage them to feel safe.
Yes.
And also, can you remember, Tom, there was, I think it was 2017, it might have been around that time. I think an Amazon data center had some sort of outage, and quite a few customers actually just lost their data and never got it back. And there's no kind of comeback on, in the terms and conditions. It's kind of like, if you lose your data, well, if we lose your data, it sucks to be you. You should have a backup somewhere else.
Yes. This is one of those things that I pointed out when it was Google that lost people's data, and people freaked out about it, as they should. But there's actually a clause, and when I did a video about Google and the data problem, I put together the 3 different terms and conditions from Azure, from AWS, and Google of you are responsible to back up your data you put in our cloud. They're very clear on that. It is in, if anyone wants to take the time to read through the legal forms and know where to look, it's all in there very clear as if we misplace all that data you stuck in here, I mean, we're going to do the best effort to keep it, but it's still your problem to back it up. And people don't realize they have to back up their cloud until they've lost something, it's been deleted. And I think going forward onto the cybersecurity topic a little bit, you're going to see more attacks where people find someone's data in the cloud and purge it. They're going to attack some of their cloud infrastructure. They're going to go after their access levels in AWS, compromise someone's key and hold that data for ransom. Well, we've already watched them exfil that data frequently because they're not pulling it necessarily off of on-prem. When you see them like, hey, we're going to publish this data unless you pay us money, they frequently pulled that all out of their cloud systems right now. But the next step would be, destroying that data in the cloud. I think the reason they don't as often is it's hard to put it back. It's not just encrypting in the cloud. From a ransomware operator standpoint, it's hard. Because some of these companies have massive amounts of data in their clouds.
Even for the home user as well, a lot of people think if it's in the cloud, that's fine. But you should still do the 3-2-1 backup rule. The cloud is just one of the backups.
Yeah.
It's not all 3 in one.
Right.
So.
Yeah, having a couple copies and always validating that those are working, that a process by which to pull some data back.
Yeah, that's a really good point as well, Tom. You're saying that, people do need to test their backups. So they're not just finding out and hoping and crossing their fingers that the backup's okay when they actually need it.
Yeah. That's the popular problem is people run into is that they don't realize that they didn't know how to restore something until they're doing it. And unfortunately, they're almost always doing it under duress of, we need this now. I've been messing with it for the last 2 hours or a day, and now it's go time. People are actually going, I really need this data now, and realizing they never really validated how that system was working.
Well, thank you very, very much for your insight today, Tom. It's been a real pleasure talking to you. I've really enjoyed chatting to you today, and I'm sure all of the users undoubtedly left a mark on them with your knowledge listening to this today. Again, I would like to just ask you, how can people get hold of you? Where can they reach out?
Everything is centered around lawrencesystems.com. I make it really easy. That's where you'll find connections to my forums, my videos, and all the socials that whenever you're listening to this, whatever I'm connected to, I'm very adamant about keeping that up to date. So I'm always easy to find, easy to get a hold of, or easy to message.
Thank you very, very much, Tom. Again, I've been a great fan of yours for many years, and it's been wonderful meeting you. Thank you very much for joining, and thank you everyone for tuning in. Till next time, keep pushing the boundaries of your home lab. So farewell and happy home labbing.
Thank you.
Bye-bye.